All right. Shh. On our next unit, we won't be doing very much with parallel lines, a little bit, but not a whole lot. It's all about triangles. Okay? And most of what we're going to do today will be things that are reviewed for you for things that you already know. Thank you, Jake. All right. So starting with classifying triangles. So remember that a triangle is a polygon with three sides. And we've talked about polygons before because it came up in our logic unit. Things like hexagons and octagons and all kinds of other ones. Yes, ma'am.
Do you have to write a ton of homework for this section?
No.
So it's not like exactly like how it was with logic.
Oh, no. Much less. The logic unit probably has more writing than any other one, probably followed by the congruent triangle unit, which is the one after this unit.
Okay.
Well, try not to pile them all on you, one right after the other. So, with a triangle, we can classify it either by its angles or by its sides. So, first of all, if all three of the angles in the triangle are acute, it's an acute triangle. Okay? By the way, that makes a really good true-false question. True or false? If a triangle has an acute angle, then it's an acute triangle.
False.
Why?
It has to have three.
Yeah, it has to have all three. Okay? And in fact, if you have a right triangle or an obtuse triangle, well, they have acute angles in them, don't they? Okay? Because at least in the geometry that we're studying, you can only have at most one right angle or one obtuse angle. Yes, there are other geometries where you can have more than that. I can see Colton thinking about it.
How?
Well, take for example in spherical geometry. Okay? So imagine, if you will, a globe and the equator. Got it so far?
Yes.
All right. Every longitudinal line, those are the ones that go through the North Pole and the South Pole, is perpendicular to the equator, right? So if you took two of those, so the equator is one side of the triangle, the two longitudinal lines are the other two that meet at the top, that makes a triangle and it's got two right angles.
What? Is it almost like the X, Y, and Z graph? Like axis?
Kind of. Just,
That's too much for me.
does that make sense?
No. I think we should wait math.
So here, I'll try and draw it for you. I think so. So if you've got a sphere, right? So here's the equator, right? If you have a longitudinal line, where it meets the equator, it's at a right angle, right? So now in 3D, it kind of looks like that, but this is a right angle. And so, yeah, that one's really bad. Just pretend that it is.
This is kind of curvy.
Yeah, so this triangle, which has three sides, has two right angles.
That makes perfect sense. Sides can be curvy?
On spherical geometry, they are.
Oh.
Yes.
I was actually wondering this, like, in science. If you took a shape, I don't know, if you took, like,
Okay.
so, like, triangles are 1, 2, 3, and then squares, let's say, are 1, 2, 3, 4, and then there's pentagons and hexagons. If
Sure.
you did enough sides, would it look circular?
Absolutely.
Circular. Yeah.
Yeah, no, you're exactly right. If you have a regular polygon, which is one where all the sides are the same length and all the angles are the same measure, and you had, even something as low as like 30 or 40 sides, you wouldn't be able to tell it from a circle.
Wow.
Then how come you said that polygon is a thing with the same sides and angles? So how come?
No, a regular polygon is one where all the angles are the same size and all the sides are the same length.
Are triangles special polygons?
Yes, it's a polygon with 3 sides
Why does that make it special?
because it doesn't have 4 or 5 sides.
But some of them have 8 or 9.
Right. It's just a classification of polygon.
Okay.
It's a subset. The big group is polygons. Triangle is a smaller group out of that. Okay? All right, so an obtuse triangle, you guys know about that. It's a triangle with an obtuse angle. One that may be a new term for you, although I don't think so. You've heard of equiangular? No? Okay. So let's look at the word. First of all, let me point out there is only one L in equiangular. It's not equal angular. It is equiangular. Angular. It's, you said angular. It can be difficult. So EQUY, what do you think that means?
Equal.
Equal, they're the same. Angular, angles, I mean it tells you what it is right there in the word. Equal. So all the angles are congruent. These will always be, at least in Euclidean geometry, which is what we study, or planar geometry. Don't worry, don't make that face.
What's it called?
Euclidean.
Bro, that's
Name-
a big word.
Yes. So is university. You hope to go to one someday, right?
Oh, wait, geometry's kind of a big word too.
It's also what acorns say when they're little.
I have a question.
When little acorns grow up,
Is it tree? That's the puppy.
they say, gee, I'm a tree.
That's
Yes.
a pretty good one.
You know, they would
We're
always
never
tell
going to get through this lesson.
everybody, all the geography teachers would tell us that like geo was like Earth.
Right.
Whatever. Is geometry like Earth math?
At the end, the metry means measure. It literally means earth measure. And that's partly because a lot of the early geometry came from needing to survey land.
I've been wondering that for a really long time.
But that's why. And a lot of it came out of Egypt, honestly.
Squares.
Well,
Wait, how did squares make a pyramid?
we'll talk about that another time. But so what would happen is the Nile River floods on a pretty regular basis, or at least used to. And so what would happen is a lot of the markers that they use for this is where your land ends, this is where my land begins, got washed away. And so they would need to resurvey the land to set up the markers again. And so a lot of geometry was because it was a practical thing. It wasn't just something that they used to torture students like it is now.
At least you
Lots
know
of things
this.
we do in school are really pointless. Like they're only there to like be there.
Okay.
To make us jump through hoops.
There's probably some truth in that. What I would say though is that an awful lot of it may not be specific to you, but it's two things. One, some of them are worthwhile knowing just in general to have a broad spectrum of knowledge, and two, can you learn difficult things? That's part of what education judges.
You're talking? Yeah.
All right.
I know.
So that's equiangular. Equiangular triangles will always be acute. Okay, we can also classify them by sides, scaling, isosceles, or equilateral. And I think this is why people think that it's equiangular, it's equilateral. People say equilateral, and it's equal equilateral, which is slightly different. Do you hear the difference?
Can I still say equilateral?
You can, if you want to be an uncultured Philistine.
Philistine?
She already is.
Never
What's
mind.
A Philistine?
Like the Philistines?
Like Goliath.
Oh, you were like saying it wrong?
No.
Wait.
They're both acceptable
That's
pronunciations.
just so.
All right, so equilateral means it has 3 congruent sides. I do want to point out one thing here with isosceles. A lot of people know isosceles not quite correctly. The definition is that they have at least 2 congruent sides. So an equilateral triangle is a type of isosceles triangle, by the way this is defined. All right, real quick, let's run through this and let's classify these by their side lengths. Triangle KYR, what kind of triangle is that? Isosceles, because it has 2 congruent sides. What about YRA? We're doing it by its side lengths. YRA, we don't know that 2 sides are congruent, so that is scaling. And what about KYA? Also scaling. Yes?
Oh, never mind.
Okay. Moving on. Page 2. Let's classify each of these triangles by its angle measures. So first of all, triangle JAM certainly looks like it's acute. The biggest angle appears to be this 80-degree angle, and so this is an acute triangle. What about triangle AME?
It's right.
Why, Colton?
Because 80 and M are a
Wait, M? What?
the other side of 80.
Yeah, what's its name?
They're a linear pair.
Yeah, what's the name of this angle?
Oh, supplement.
This angle's name.
Oh, AME.
Thank you. Angle AME are, go ahead. They're supplementary, yeah, because they are a linear pair. Linear pairs are not going away. You're going to have them over and over and over again. So this is 100. So that means that this triangle is obtuse.
That does not look like 100 degrees.
Okay. And then triangle JAE certainly appears to be what kind? Acute. But there's more to it than that.
I knew it. There's a butt
It's obtuse.
How can it be obtuse?
Right? Wait, no, JAE. Because, it measures 180, 60 plus 20 is 80 less.
Whoa, hang on. This whole angle's not 20.
Oh,
This angle's 20.
my bad.
But you are alluding to something that I do want to talk about. Could we find out how big angle E is?
Yeah, technically.
Yes.
Yeah. How much do these angles theoretically add up to?
120.
180. So far we've got 120. So we need another 60. And then let's see, 60 and 80 is 140. From 180 leaves 40. So this angle is 60. So what kind of triangle is,
Equilateral.
yeah, equiangular. Equi.
Equiangular. I didn't see one. You have to cut both here and
Equiangular, yes.
You have to cut both of them.
Yes.
Why?
Because it said classify it. We want to fully classify it.
So it can be under 2 classifications.
Yes, it can.
Sammy, there's your mom.
All right. So the triangle sum theorem, I think all of you know this already. We just talked about it. The angles in a triangle have to add up to 180. Do you know why?
Because I don't know. Because math said so. It's postulate.
Because math said so.
Square is 360 degrees and half.
How do you know a square is 360?
square sum theorem.
It's
Then
four
why
right. It's
can't
four
we-
right angles.
Then why can we go?
But this isn't half of a square.
You cut a square in half, you get two triangles.
Yeah. But you wouldn't get this triangle.
I don't know. I don't know.
Yes.
Does this have anything to do with the fact that if you like turned around in a circle, you go 365 degrees?
You go 360 degrees, not 365.
Whoa.
Wait, 365 is days, right?
Yes, that's days in a year.
Yeah.
Oh shit!
The guy on Shark Tank said that there were 365 weeks in a year. There's a billionaire one.
365 weeks in a year?
Which one?
He was like, I spend an hour making my bed every week, which means I spend 365 hours a year making my bed.
Yeah.
Which one said that?
All right. So,
It's not my brain.
here, let me show you real quickly two things. You can put your pencil down for a second and just watch and listen.
That was really impressive.
So, I'm going to draw a line through S parallel to RT. Do you guys all agree that there's only one such line that exists that would go through S that would be parallel to RT?
Yes.
Yes.
Okay. And for convenience sake, I'm going to label these angles 1, 2, and 3. So what do we know about the sum of the measure of angle 1 and the measure of angle 2 and the measure of angle 3?
It's 180.
It's 180. How come?
Because,
It's a straight line. Because
Yeah.
of that
Linear
triangle
angle?
sum
Now, it's
theorem.
not a linear pair,
Is it
because there's...
triangle sum
Just
theorem?
open-
No.
It's half a
One in
circle.
angle SRT or alternate interior.
Well,
angles.
we'll get to that. I'm just talking about 1, 2, and 3.
There's supplementary.
Well, they're not, because supplementary requires that they be two angles.
They're a straight line. Right?
It's
Yeah.
not. It's
Well,
not-
sort of. Together they form a straight angle. Right?
She said that.
She said they form a straight angle?
Yeah. That's straight line.
Yeah, straight line, straight angle, not quite the same thing, but pretty close. And
How is
then,
it an angle if
as
it's
Jake
straight?
was pointing out, pardon?
How is it an angle if it's straight?
It's 180. So it's like.
An angle, by definition, is the union of two rays with a common endpoint. The joining together. Union means join something. So we could join them together like this.
Oh, that's fancy. I could never figure that out.
And that's a straight angle. All right. So, and then, as Jake pointed out, angle 1, and you could just call it angle R, are alternate interior angles. So they've got to be congruent because they're formed by parallel lines. Likewise, angle 3 and angle T are alternate interior angles. So that means the measure of angle R plus the measure of angle 2, which we could have called angle S in the original figure before we added other stuff in, plus the measure of angle T is 180.
So it's an
So we use
equilateral-
substitution?
No, they add up to 180. We don't know what each individual one is. Okay?
Is there a word for that? Like we have supplementary, but like
For 3 angles, no. At least not that I know of. All right, let me also show you, hang on just a second, the lovely sounds of the snot serenade.
it's disgusting. Disgusting.
Literally has been happening.
I'm sad.
Oh, it's kind of my fault, but it's still
Mr. Davis,
Yes?
I was in the library. I looked through the yearbook from like 10 or 11 years ago, and you look the same. So I don't think you were ever young. Until you can prove it with like evidence, I don't think you were ever young.
All right, so
That's not nice there.
here's another way that I can demonstrate to you that the angles in a triangle have a sum of 180. I have here an ordinary triangle. There's nothing special about it. There's no tricks.
It's yellow.
See, nothing up my sleeve. If I folded this triangle, I could fold the top angle down so that it touched the bottom side. And then I could fold the left side in until it met that same point.
Like an envelope.
Yes, and then fold the right side in like this.
So you do that with every triangle?
When I do that, yep, it doesn't matter what the triangle looks like.
Can we test it?
Well, if you want to later on cut out some triangles, you do have to be careful. The two things you have to do, one, you have to make sure your triangle, the sides are all straight. And then the first fold that you make, you have to do it so that this fold right here is parallel to this side. That's the only thing you have to do, and it's not a lot of work. Okay? But I can also show you the angle measurements for this. There are the angle measurements. It adds up to 180 degrees exactly. Okay, let me reset this.
Is there ever an exception to that?
Nope. And if I was to drag around this point, notice all those angle measurements are changing, aren't they? But the sum is always 180, no matter what.
That's crazy.
It's pretty cool.
Can you fold it again?
Sure.
I just like watching it.
No. And now you can see these three angles together make a straight angle, so that's 180 degrees.
Who figured that out? Who had time and the will and the idea? Who figured why?
Originally, I don't know.
Someone extra smart.
Not you.
All right, moving on. Let's find the indicated angle measurements on this. We'll do the first one, which is like what you would do in your 7th grade math class. And then we'll do one that requires a little more thought. So for this first one, we're trying to find the measure of angle RST. So that's this angle up here. How can I find that angle's measure?
Add those two.
Add those two. You have to be way more specific.
R and T.
R
The angle R and angle T.
angle. There is no angle R in this picture.
So it could be
Angle SRT and angle RTS.
SRT and RTS. Okay. Or you could have just said SRT and T. But you cannot call any angle in this picture angle R because no one knows which angle you're talking about. So adding the 62 and the 40 together. So 62 plus 40 is what?
102.
102 from 180.
78.
78. And again, that's sort of a junior high question. Pretty easy. Okay. It was the face you made when I said that's a pretty junior high question. A slightly more difficult question would be to find the measure of angle SQR, which is also called angle Q over here. There are two different ways that you could find that. Take a look at this and see if you can find one of the two ways. I will tell you, we did this lesson in my regular geometry class yesterday, and both classes figured out both ways on their own. I will be terribly disappointed if you don't do the same.
We'll get ready to break the kitty for you.
We could figure it out.
Jake, did you have a thought? Oh, you have a thought? Okay. Yes?
You could say you could find the supplement of angle SRT
Because those are a...
near error.
Yep, we could find this angle right here by taking 180 minus 62. Oops. Keep thinking I'm hitting it, apparently not hard enough. What the heck, man? That's just bizarre. I think I'm just going to rage quit now. That's bizarre. It's not working at all now.
Okay, I guess I'll listen over.
Hang on just a moment. When in doubt, restart the application. There we go. So we found that this angle was 78. And then we can do 180 minus 62, which is
118.
118.
Yeah.
And then from there,
We add it up, we get 130. We take
add it up.
add QRS and QSR and QRS up. We get 130. We take that out of 180, and we get SQR is 50 degrees.
Exactly right.
Yeah.
Boom.
So that's one way you can do it.
What's the other way?
I don't know. That's what I'm asking you guys. What's the other way that we could do this? Yes.
Is it the, wait, is that 78 at the top at point S? Is that 78 or 75?
It's 78.
Bro, you're wrong.
It's like,
It's not hard to see, okay? 78, same side interior, not same side interior, alternate interior angle down to QRS.
except we have no parallel lines, so there's no relationships with
Yeah, that was a lot.
any of those.
I love
I
that.
guess.
Wow, what a wild guess.
Well,
What
like-
do you
Shot.
think?
Yes, Jake.
You can like the whole angle like SQT, like
SQT, that's this angle.
yeah, so like 78 plus 12 is 90,
Oh, so this whole angle up here is 90.
and then the 40-degree angle, and then add them, that's 130, and then subtract from 180, 50.
Very nice.
Good job, Nick.
So you can look at the big triangle also. Its angles have to add up to 180. Pardon?
There's another way, or is that the same?
This is the way we were talking about. This is the second way. So if that's 90 and this is 40, 90 plus 40 is 130. Subtracted from 180 leaves 50.
You're smart, Jake.
Okay? So looking beyond the little triangles and looking at the big triangles, that's going to come up on a couple of problems in this unit. That's going to be something you need to learn to do. Yes. Sometimes you need to look at the little details. Sometimes you need to look at the big picture.
He's serious.
Okay. Want to point out one other thing in this. What kind of a triangle is this big triangle?
Obtuse.
Alright,
Right.
scaling, a scaling.
A rectangle.
A scaling.
Oh, wow.
It is a right triangle.
See, I can do that.
Okay? Because it's got a 90-degree angle in it. Now, notice it's got two acute angles, here and here. What do you notice about those two angles?
They equal 90.
They're complementary. They add up to be equal to 90.
Bro, I forgot.
Which makes sense because all three of those angles have to add up to 180. We've already got 90 from this, so that leaves 90 for the other two. So that is something that's called a corollary. A corollary is just a theorem. It's so fun to watch you guys freak out about absolutely everything.
I didn't. Okay.
That's about.
Okay, bye-bye.
That's the
All right,
bell.
real quick. Hang with me for just a second. Shh. Sit down. Sit, 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 sit. So, in this triangle, there's a, I wrote it wrong. It should have been angle S and angle T are complementary, not R and T. And, real quick, on this last bit, we've got all kinds of other stuff. We'll pick up here
I wonder why we didn't get
Friday. Yeah, I let you guys go too far afield with our discussions today.
Just